Welcome to another tutorial. Today we will be introducing you to exponents. We will also introduce you to 6 laws of exponents, which are handy when simplifying 1. Exponential expressions and 2. Exponential equations. Let us now start with an introduction to what are exponents. Say you're given an expression such as 2 times 2 times 2. That is 2 multiplied by itself 3 times. The shorthand method of writing this expression would be a 2 raised to the power of 3. This number on top here, we call it an exponent. And the number 2, we call it a base. Let's look at another example. Say you're given an expression a multiplied by a multiplied by a and multiplied by another a. That is a multiplied by itself 4 times. The shorthand notation of writing the expression would be a multiplied by itself 4 times. Again, this top number here is referred to as an exponent, and the letter A is referred to as a base. Let's look at one more example. Say you're given an expression 7 multiplied by 7 multiplied by another 7 multiplied by 4 and multiplied by another 4. In this case, we have 3 7s, so the base is 7 and the exponent is 3. And then we have another expression which has a base of 4 and an exponent of 2. Again, these numbers here, we call them bases. 7 is a base and the 4 is a base, whilst the 3 and the 2 are called exponents. It's an exponent. This ends our introduction to exponents. Now we're going to start looking at the laws of exponents. Let us now look at laws of exponents. Our first law says if you're given 2 expressions, say a with an exponent m multiplied by another a with a different exponent n. Our law says if we have a product, that is multiplication of 2 exponential terms, whereby each term has the same base. Here our base is a and the second term has the base a. What we can do, we can write down the product of 2 expressions with the same base as one expression, whereby the exponents m and n are added together. This is our first law. So for our first law, that deals with the products of exponential terms, whereby the bases are the same, can be written as one base with the exponents added together. Let's now move on to our second law of exponents. This law of exponents deals with division of two exponential terms. Let's use the same exponential terms. In this case, we divide the first term raised to the exponent m by the second term a raised to the exponent n. In this case, the law says that if the bases of these two terms are the same, we can write the expression as a raised to the power of m minus n. So for division, so we say here bases must be the same. Right? So for division of exponential terms with bases being equal, can be written as that base, in this case a, with the exponent on the top of this expression being the first one, subtract the exponent at the bottom. That's what our second law says. Let's now look at the third law. The third law has to deal with an expression, say a to the power of n, raised to another exponent. This law says we can rewrite this expression as a raised to the power of m multiplied by the exponent. Now let's move on to the fourth law of exponents. This law of exponents says if you have two terms with different bases, two different expressions, say you have a multiplied by b raised to an exponent. Let's rewrite this so you can see where we're going. Say we have a raised to the power of 1 and b raised to the power of 1, all raised to the power of n. The law of exponents says you can rewrite this expression, you can simplify this expression by multiplying the exponent 1 with the exponent outside and multiplying the exponent of b, in this case is 1, by the external exponent. And the law essentially says that a times b raised to the power of n can be written as a to the power of n, b to the power of n. Let's now look at our fifth law of exponents. This one is simple. It says if you have an expression raised to the power of a negative 1 or a negative number or a negative exponent, this can simply be written as 1 over the expression to the positive number, or simply 1 over a. Let's look at our sixth law of exponents. The sixth law says if you have an expression raised to the power of 0, reduces the whole expression to simply 1. These are our 6 laws of exponents. Let's recap. The first law says if you have a product of expression where the bases are equal, we can simplify this expression by just simply adding the exponent, placing it as an exponent of a. The second one, it says if you have a division of two terms, these terms having the bases which are equal can be reduced to just simply the base raised to the power of subtraction of the two exponents. That is the top one minus the bottom one. The next one says if you have a term within brackets raised to the power of n can be simplified as the term within the bracket with the exponents multiplied. The fourth law of exponents simply says if you have a product of two terms in brackets raised to the power of n, in this case we have the term a raised to the power of 1, b raised to the power of 1, all raised to the power of the exponent n. All we simply do is multiply the exponent of the first term with n and the exponent of the second term with n. And this is exactly what we have done here. And this simplifies to a to the power of n, b to the power of the n. And the fifth law of exponents says if you have a raised to a negative 1, that is a term raised to a negative 1, this term can be written with a positive exponent by just simply saying 1 over that term to raise to the positive exponent, or simply 1 over a in this case. And the last law of exponents says if you have a term raised to the power of 0, this whole term simply reduces to 1. We now going to move on to the next video and see how to apply each of these laws in simplifying exponential expressions or exponential equations.